Okay, what you have here is a logarithm equation, and we are asked to solve. What does it actually mean to solve it? In multiple questions, you say like evaluate, simplify, solve, or find. Find and solve mean the same thing. So by asking us to solve, we are asking us to find the unknown variable from this expression, which is x. So how do we solve x from this equation? To do so, let's break this 3x down by writing it as 3x times x. If that should happen, this will give me x log in base 3 times of x is equals to 9. We have multiple laws of multiple laws of logarithm, of which there's one that supports where you multiply two different powers. If that should happen, let's assume we have log AB in base 10. This can be written as log A in base 10 plus log B in base 10. That means I can write 3x or 3 times x as log 3 in base 3 plus log x in base 3. So if we apply that, this will give us x log 3 in base 3 plus log 3x in base 3 is equals to 9. So we also have a law in logarithm that supports when you have equal power and equal base. What we have here, the base and the power, they are the same. What does the law say? It says log A in base A is 1. When the power and the base is the same, the value is 1. So I can change all of these into 1. I'm having x raised to the power 1 plus log s in base 3 is equals to 9. So what happened from here? Since we have log s in base 3 and we have 9, we know there's always a relationship between 9 and 3. 3 is a factor of 9. How many 3 can I find in 9? Is 2 of it, 3 raised to the power 2. So we're having 3 as a common factor. Let's take the logarithm of both sides to base 3. So take log of both sides to base 3. So if that should happen, now we have log in base 3 x raised to the power 1 plus log x in base 3 equals to log 9 in base 3. So we actually have a law in logarithm that supports when a power have another power on top. What does the law say? It says when you have log a raised to the power n in base 10, this is the base, this is the power, this power is having another power. The law says the power is having can come back to give us n log a in base 10. So let's bring the idea here. That means this is not the power. 1 plus log s in base 3 is the power. That means it can come back to give us 1 plus log x in base 3 log x in base 3 is equals to, as we said earlier, 3 is a factor to 9. So I will write this as log 3 raised to the power 2 in base 3. Here we go again, base and power, and the power is having another power. That power can come back according to this law. So I'm having 1 plus log x in base 3 log x in base 3 is equals to 2 log 3 in base 3. Now we are still having the law is reflecting again when you have equal base and power. The law said the value is 1. So I'm having 1 plus log x in base 3 log x in base 3 equals to 2 times of 1. Because log 3 is 1, and 2 times of 1 is simply 2. So we have log 3, we have log 3 here. Let's classify it to be any variable. I will say let log x in base 3 to be m. So anywhere we see log x in base 3, we put m. So I'm having 1 plus m equals to 2. So let's open the bracket. So give us 1 times m is m, plus m times m is m squared equals to 2. So I'm having square and n in the expression. That means it's leading us to a quadratic equation. So let's arrange this in quadratic form. So I'm having m squared plus n minus 2 is equals to 0. By inviting 2 to this side, it becomes a negative value. But here it's positive, we don't write it. So when I'm inviting it, it becomes negative. So what we have here is a quadratic expression. Let's solve by factorizing it. What can I multiply to have minus 2? If I add the same two numbers, I have positive 1. the factor is plus 2 and minus 1. So let's use those two factors to exchange m. That will give us m squared plus m plus 2m minus m minus 2 is equals to 0. So I'll bracket the first two, m squared plus 2m, and the last two, m plus of 2 equals to 0. So what is common from the first bracket is simply m. Here remain m plus 2. What's common from here? 1. But ideally nothing is common, so we use 1 as a common factor. M plus 2 is equals to 0. So I can classify the two brackets as 1. I'm having m plus 2, and those outside the bracket, m minus 1 as 0. Therefore, m plus 2 equals to 0, or m minus 1 equals to 0. So from here, I can easily find my m. Therefore, my m now is minus 2 or plus 1. But nobody asked us to find m. We only substituted the value to represent m. What was that value? It's log x in base 3 as m. So here we have two values of m. So let's consider them individually. For m equals to minus 2, I will substitute it in place of m. So I'm having log x in base 3 is equals to minus 2. So we also have a law that supports base power becoming equals to a variable. So what does the law say? The law says when you have log x in base y equals to m. So to find x, y we raise m becomes s is now y raised to power m. So if I should apply the concept here, therefore my s is now 3 raised to power minus 2. So we can apply the law of negative power here in indices. So it will give us 1 over 3 raised to power 2. Therefore my s is now 1 over 9. So this is for m equals to minus 2. Let's also consider it for m equals to 1. For m equals to 1, we're having log x in base 3 is equals to 1. The same law that says log xy equals to m. To find s, this base will raise whatever I have. So s becomes y raised to power n. So let's apply it here. So my s becomes what? 3 raised to power 1. S is now 3. Therefore, the solution to the equation is s is 1 over 9 or 3. So if you like what you are watching, subscribe, support the channel, turn on your notification button, and comment. Thank you.